We're now going to create an ADC example. And just like for the DAC, we're going to create this one from scratch. To digital converter. And as before, if we could import from the symbol or an empty model, but we're gonna go ahead and type it in from scratch. We're gonna have this 8-bit output, signed in input, and the input will be a differential voltage of a clock. Input will be digital. Have a enable input, digital, the bias input, high bias, and we'll have our supply and ground. I'll put in a little description for each. Output, input, and these descriptions just end up in the comments in the code. Enable, put bias, current to ground. Positive, supply, and ground. Now let's go ahead and set up some of the behavior. And again, just like before, we're going to set up the behavior of the supporting pins like enable. This time I'm going to set something called alive equals enable, and just like for the DAC, we're going to do not fault. Now the alive signal is going to go into the output, but the output this time is a digital output. So instead of smoothing it, we just need to protect it. And protecting it just means we're going to protect it from an X. Okay? So this will make it so that that enable can't be an X when it goes to the output. And so I'm going to set up also Vin equals Vd for the differential voltage. Now, in this case, we're going to sample the input. We can use another table called the discrete variables table to set that up. So I'm going to create a discrete variable called sampled. We're going to sample a real number. This will be the sampled input. And the value it's going to sample will be Vin, right, the input voltage. And the trigger will be pause edge clock. So the behavior then is just alive times, and we actually have a function for an ADC sampled from the input will be -1 to 1, and the output will be 256 levels. I can also set up the assertions then. I'll do the same as I did before. Say the I bias is to be 1 microamp, so I can do the same thing, 0.9 microamps to 1.1 microamps when enable for 1 microseconds. VDD is 2.3 volts to 2.7 volts when enable for 1 microseconds, and ground is -10 millivolts to +10 millivolts. Now I can go ahead and generate the model. Just like before, the model's down here, and this model is 235 lines of code.
Oh, I see that it did not change the name of the cell. It's still at a default. I will go ahead and change it. We're going to go ahead and select that we're going to change the model name. Change that to amp. Go ahead and generate and view again. And now we get the cell name to be amp.
Thank you for watching. Please click in the upper left for our next video. Please click in the lower left for the playlist of all of our videos in the series. Please click on the right to subscribe to our channel.